Okay, we will go through some important points in the class 12 chemistry chapter 13 amines. Okay, amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia by aryl or alkyl groups. Okay, aryl means that's aromatic benzyl ring groups. Okay, this synthetic amino compounds used in the as anesthetic. Okay, here nitrogen orbitals of the amines are sp3 hybridized and the geometry of the amines is pyramidal. Okay, due to the presence of the unshaded electron pair, the angle CNE, carbon nitrogen, E can be carbon and carbon or hydrogen. So this is the angle 109.5 degrees, and this is the structure. Okay, pyramidal structure of the these amines. Okay, amine they are classified into the primary, secondary, and tertiary depending upon the number of hydrogen atom replaced by the alkyl or aryl groups. Okay, if one hydrogen atom replaced, then it is primary. Then this is secondary, two hydrogen are replaced, and this is tertiary. Okay, this is ammonia. We replaced one hydrogen atom with this is primary amine. This is secondary amine. Here two hydrogen atoms replaced by alkyl or aryl group. This is tertiary amine. Three hydrogen atoms are replaced. Okay, over the IUPAC nomenclature of the amine. So GHNHD is methylamine. So we use di-tri-prefix attached to the amine. Okay, based on the number of groups attached. So this here the secondary amine we use this N. Okay, here we have the secondary amine, that is N methyl ethanamine, and the tertiary we use NN. Here we are using NN for the tertiary amine. Okay, diethyl ethylamine. Aryl amines NH2 group is directly attached to the benzyl ring. This compound is aniline compound. Is the simplest example of the aryl amine. In common system, it is known as aniline. Okay. So here these are the various compounds, the common name and the IUPAC name. So here we see a secondary amine. Okay, it is attached, two hydrogen atoms removed. So this is N methyl ethanamine. Okay, here N is used. This is tertiary amine, NN is used. Okay, here we have alkene double bond. So we use En. See here, to En we are using. Okay, this is aniline. Preparation of the amine. Reduction of the nitro compound. So the nitro compounds on reduction gives this aniline. Okay, so reduction with the iron swap and the hydrochloric acid is preferred because there are two kind of reduction here. So they are preferring this reduction because this official formed gets hydrolyzed to release the hydrochloric acid during the reaction. Thus only a small amount of hydrochloric acid is required to initiate the reaction. Okay, ammonia lysis of the alkyl halide. This is the second way of preparing the amines. This process of the CX bond by ammonium is ammonia lysis. This is how it reacts. Nucleophile. Okay, the negative attacks this positive ion here. So amine substituted ammonium salt. Ammonia lysis has the disadvantage of yielding the mixture of primary, secondary, tertiary amine and also the quaternary ammonium salt. So it is not giving one as the major product. One of it is giving mixture of various amines. The order of the reactivity with the halides with the amine. So iodine greater than the bromine and chlorine. Okay. Reduction of the nitriles. Nitriles on reduction with the lithium aluminum hydride. Lithium aluminum hydride or catalytic hydrogenation produce primary amines. So this is the reaction. The preparation of the amines containing one carbon atom more than the starting one. Okay. Here the amines will have the one carbon atom more than the starting nitriles. Reduction of amides. This is Gabriel-Thalhamide synthesis. It is only for the synthesis of the primary amines. Okay. Aromatic primary amines cannot be prepared by this method. Only alkyl primary amines can be prepared by this method. Okay. Thalamide, KOH, this reaction on heating it gives this product. Then the hydrolysis we get the amine. Primary amine. Only alkyl primary amine. This is Hoffman-Bromomere degradation reaction. Developed a method for the preparation of the, this is also for the primary amines, by treating the amide with a bromide in an aqueous or ethanolic solution of the sodium hydroxide. So this amine is formed one carbon atom less than the present in the amide. Okay, this is degradation reaction. So the resultant amine will have one carbon atom less than the present in the amide. Physical properties. The lower aliphatic amines are gaseous state. Okay, and physical primary amines with 3 or more carbon atoms are liquid. Okay, the lower aliphatic amines are gaseous state and 3 or more carbon atoms are liquid and still higher are solid. Okay, aniline and other aryl amines are usually colorless but get colored on the storage due to atmospheric oxidation. Higher amines are essentially insoluble in water. The order of the boiling point of the isomeric amines. Okay, isomeric amines. They have the same molecular formula, isomeric amines. So the primary is greater than the second equation and tertiary, the boiling point. Boiling point are the isomeric amines. The intermolecular hydrogen bonding is more in primary amines. Okay, because this has more number of hydrogen atoms. The basic character of the amines depends on the various upon the plus the inductive effect plus steric hindrance plus the solvation effect. Okay, amines are basic in nature. Basic in nature react with acid to form salts. Okay, aniline, the base react with acid, this forms salt. Okay, amine salts are soluble in water but insoluble in organic solvents like ether. Okay, this reaction is the basis of the separation of the amines from the non-basic organic solvent insoluble in water. Amines have the unshared pair of electrons on the nitrogen atom, so they are behave as a Lewis base. This is how you compute the basic strength of the amines. So Kb values, more Kb the stronger the base. pKb values lesser means the more stronger. Aliphatic amines are stronger bases than ammonia. Okay, aliphatic amines are stronger bases than ammonia because of the positive inductive effect of the alkyl groups. Okay, the aromatic amines are weaker bases than the ammonia due to the electron withdrawing nature of the aryl group, because there is a resonance okay, inside the aromatic ring. So aliphatic amines more basic strength is more than the ammonia. This is ammonia is more than the aromatic amines. This is the pKb values. Lower means higher strength. pKb. Kb means higher basic strength. This is positive inductive effect. Besides inductive effect, there are the other factors like solvation effect, steric interaction, which affect the basic strength. So that is important. Structure basically basicity relations means, okay, the more stable carbon in relative to the amine, more basic in nature. More stable the carbon in relative to the amine, more basic is the amine. Due to the electron releasing nature of the alkyl group, this is plus inductive effect. Alkyl amines are stronger bases than ammonia. The order of basicity of the amines in the gaseous state. So we have a tertiary amine greater than a secondary because tertiary will have more alkyl groups. Solvation also effect also matters in terms of determining the basic strength. The stability of the ions in this order, okay, decreasing order of extent of the H bonding in water, the order of stability ion by activation, by solvation. The order of basicity of the alphabic amines. So if you add the, so this is primary greater than secondary, which is opposite to the inductive effect. Okay, this is based on this solvation. In case of alkyl that is bigger than CH3 group, there will be a steric entrance. Okay, so C2H5 will have more steric entrance than CH3. So if you combine all the three properties, induction effect, solvation, steric entrance, this is the basic strength of the amines, methyl series, ethyl series. Okay, you see the difference here. Okay, so the 3 molecule here, but the 3 molecule is here, 1 molecule here, 1 molecule. RL amines versus ammonia. pKb values, they are quite high. That means the basic strength is low. It is because aniline and other RL amines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on the nitrogen atom to be conjugation with the benzene ring, and thus making it less available for the protonation. So it participates in the resonance like this. We know that greater the number of resonance ring touches, greater the stability. Thus you can infer aniline, the resonating structure is more stable than anilium ion. These are the examples of the electron releasing group, and these are the electron withdrawing groups like NO2. Acylation, anhydrates and ethers. Anhydrate and ethers, they react by nucleophilic substitution reaction. This reaction is known as acylation. The product obtained by acylation reaction is known as amides. Okay, the reaction is carried out in the presence of the base stronger than the amine, like pyridine. This removes HCl so formed and shift the equilibrium to the right hand side. Pyridine removes the HCl. Methylation. Carbolamine reaction. This is for the primary amines only. Secondary and the tertiary amines do not follow this reaction. Carbolamine, this is the reaction. Okay. Nitrous acid. Primary aliphatic amines, react with nitrogen to form aliphatic diazonium salts, which is unstable and rebate nitrogen get quantity. So aliphatic diazonium salts, they are unstable. A reaction with the orbital sulfonyl chloride, that is the NCERT reagent. Okay. The reaction with primary amines produces this salt. Hydrogen attached to the nitrogen in sulfonamide is strongly acidic due to the presence of the strong electron withdrawing group, sulfonyl group. Hence, it is soluble in the alkali. In reaction with the secondary amine, this is the product. Since N-diethyl sulfonate does not contain any hydrogen atom attached to the nitrogen, it does not contain any hydrogen, it is not acidic and it's insoluble in alkali. Okay, this is soluble in alkali, but reaction with the secondary amine, insoluble in alkali. Electrophilic substitution. You heard earlier that aniline is a resonance hybrid of. Where do you find the maximum electron density of these structures? Ortho para position in the NH2 group became center of the electron density. Thus, NH group is the ortho para directing and powerful activating group. Reducting NH group by acylation with acetic anhydride. The lone pair of electron on the nitrogen atomide interact with the oxygen atom due to the resonance force. Hence, the lone pair of electrons on the nitrogen is less available for the donation to the benzene ring by resonance. Therefore, activating the effect of this group is less than that of the amine group. Nitration, anilinium ion, which is the meta directing. Here is the meta directing. So here nitration is in meta position. However, protecting NH2 group by acetylation reaction with acetic anhydride, the nitrogen reaction can be controlled and the para derivative can be obtained as the major product. So here we obtained the in ortho, para and meta. If you want to only most major para product, then we have to, the reaction can be controlled with the acetylation. Aniline does not undergo this Peters-Krebs reaction, alkylation and acetylation due to the salt formation with aluminum chloride. With Lewis acid, which is used as a catalyst, due to this nitrogen and aniline acquires positive charge and acts as a strong decay-agitating group. Diazonium salts. These have the general formula like this, where R stands for the aryl group. Okay, diazonium salts, R here aryl group only, and X is ClBr. Primary aliphatic amines form highly unstable alkyl diazonium salts. Okay, highly unstable alkyl diazonium salts. Due to the instability of the diazonium salts, it is not stored and used immediately after the preparation. Nitrogen bomb escapes. Sandmass reaction, this is with chlorine bromine only. Okay, chlorobromine only. Caterman reaction. The yield in the Sandmeyer reaction is found to be better than this Caterman reaction. Replacement by mild reducing, this is mildly reducing agent, hypophosphorus acid. This is the reaction. Coupling reaction. Benzene diazonium chloride reacts with the phenol in which phenol molecule at the para position is coupled with diazonium salt to form this E-hydroxybenzene. This is reaction is a coupling reaction. Similarly, the reaction with diazonium salt with aniline yields this okay, the following example. Okay.